So 13.5 Reflections and Symmetry. A reflection can be thought of as a flip, a mirror image. In order to make an image from a pre-image using a reflection, you must have a line of symmetry or an axis of reflection to reflect over. Okay, so let's take a look at this first example. Okay, first thing, and please make sure that you're using graph paper. First thing that I'm going to do is label each point of the pre-image. Okay, let's look at this example. First thing I'm going to do is label each point of the pre-image, and I have some kind of an error. Sorry about the error here. I don't know where this came from, all of those G's, but I'm going to, put my own letters on them. Alright, then I'm going to reflect it across the x-axis and then label the points of that particular image. Reflecting meaning flip. So let me start off with labeling, and then we're going to look at what's involved in flipping. Okay, so our first step was to label each point of the pre-image, which we did. Our second step, part B, reflected across the x-axis and label the points of the image. So here is the x-axis. So I need to count to see how many units each point is away from the x-axis and put its reflection on the other side of the line of reflection. So for example, let's flip A first. I'm flipping over the x-axis. So I ask myself, how many units is point A away from the x-axis? Point A is 7 units away from the x-axis. So since I'm flipping it over the x-axis, that means that the image should end up here. So now I need to count 7 units the other direction for where the location of A prime would be, which should be coordinate -6, -7. Here is the location of A prime. In order to flip point L, E, and X, I'm going to do the exact same thing. I'm going to count how many units is each point away from the x-axis and put its image that many number of units on the other side of the x-axis. We have reflected each individual point over the x-axis. And now here we have the resulting coordinates of the image. From this, we should be able to figure out a rule to help us to figure out what the coordinates would be without going through this process. So we start with xy, okay? Look to see how did x change, how did y change. X did not change at all, and the only thing that changed about y is that it happens to be the opposite coordinate, so -y, and that would be it. For any time that we are flipping over the x-axis, this is going to be the rule. Now we're going to do the next part. We're going to go back to our pre-image, which is Alex, right here. We're going to go back to our pre-image, and now we're going to flip it over the y-axis. Okay, we're going to flip it over the y-axis and label the points of the image. Okay, in order to do this process, now because I'm flipping over the y-axis, now I'm going to count to see how many units is each point away from the y-axis, and then count that many points onto the other side of the y-axis. So, for example, point A happens to be 6 units away from the y-axis. So I must count 6 units in the other direction, making sure, of course, that I'm on the exact same line as point A is. My A double prime will be located here. 6 units away from the point of reflection, from the line of reflection to the pre-image. And now I'm going to do the same thing for the rest of the point. Okay, so at this point we have now reflected the pre-image Alex over the y-axis. Now we should be able to figure out a rule. It's kind of like a shortcut on how we can figure out these coordinates ourselves. So when you're starting out with coordinate xy, look at what changed. Look at the x coordinate going from, you should be looking from the pre-image to the image, from the pre-image to the image. And so hopefully you'll see that the x value is now its opposite and the y stayed the same. This is going to be the rule every time we are reflecting with respect to the y-axis. Okay, so for this example, we're going to do something, it's pretty much going to be the same, but there's a little change. X equals 2. Remember, x equals a number. This is a vertical line that passes through 2 on the x-axis. So here's the x-axis, here's 2. Okay, x equals 2 for the first part is our line of reflection. So first thing that I'm going to do before we do any reflecting, I'm going to go and label my points. This time I'm going to go, okay, so in order to reflect with respect to x equals 2, what I need to do is reflect each point. Starting off, I need to see how many units is r away from the line of reflection. Because the x coordinate of r is at -6, I know that it's 6 units to the y-axis, but we're not flipping over the y-axis. So another 2 is actually 8 units away. Yes. So if r is 8 units away from the line of reflection, its image must also be 8 units away from the line of reflection. So 8 units from the line of reflection will put me here. And this would be r prime. And now for me to reflect y, I need to see how many units is y away from the line x equals 2. Now y is, we just count, 1, 2, 3, 4. So I need to go 4 units the other direction. Here's a perfect example of why you should know your points before you create your graph so that things like that don't happen. But anyways, all right, so we have reflected the pre-image with respect to line x equals 2, listed all of the coordinates. A is 1 unit away from the line of reflection, so its image must be 1 unit away from the line of reflection. So A prime would be here. Y is 1, 2, 3, 4 units away, so its image must be 4 units away the other direction. 1, 2, 3. Okay, so now we have finished reflecting the pre-image with respect to the line y equals 2. I want you to notice that because point N was directly on the line of reflection, that means that its image has to also be directly on the line of reflection. So N and N double prime share the exact same. For our last one, we're looking at how would we reflect the pre-image about the line y equals x. Y equals x is a vertical line, a diagonal line that rises through the origin. Y equals x is a diagonal line that rises through the origin. Okay, it's not the best line, but it'll do. Okay, so now it's time for us to reflect our pre-image with respect to y equals x. This time our points will be referred to as triple prime. We'll be using triple primes because this is the third image. Okay, so let's start with r. And so it has been flipped with respect to y equals x. And there is a rule for problems like this. Maybe you can, and we'll talk about it. You start with xy. Look at how we got to these points. Look at the similarity, what's different. And we'll see if you can figure out the right answer for that. Okay, what is reflectional symmetry? Reflectional symmetry, also known as line symmetry, means you can draw a line of symmetry through the shape, make sure that it's a straight line. If you were to fold your paper on this line, the shape should be able to match up exactly right on top of itself. Okay, so let's look at some examples of this. Okay, so I'm asking you to please copy down all of these shapes and the various lines that are drawn. All right, here's the way that we do this. You're trying to see if you were to draw a line through the shape. If you folded the paper, would it line right on top of itself, meaning edges to edges and everything? So I know that if I took this rectangle here, if I drew, I do mean that line to go right down the center. Anyways, if it did, and I were then to fold the left side on top of the right side, the edges would line up. So that means that this figure does have reflectional symmetry. Likewise, if I were to draw a horizontal line and then fold it top to bottom, the edges will line up, so therefore it has reflectional symmetry. When you are requested to determine whether or not a shape has reflectional symmetry, you do have to draw all possible lines. Now, is there a horizontal, diagonal, or vertical line that I could draw in this figure here so that the edges would line up if the paper were folded on that line? No. So this shape here does not have reflectional symmetry or line symmetry. What about this heart? I think that if I'm sorry, freehand. So you get the idea. Yes, it does have reflectional symmetry. What about this oval? I can do this, and these are lines, so that's why they have arrowheads. I can do that. Can I do a diagonal line? No. Let's look at this triangle. Is there any kind of way I can draw a line so that it could line up right on top of itself? The answer is no, meaning it does not have reflectional symmetry. This nice figure here clearly has reflectional symmetry. I see that, almost had it. If I drew my line like this, or maybe even like this, it would certainly line up, edges would line up if I were to fold it. Is that it? Are there only these two lines? What about, oh my God, that's horrible. Okay, it's slightly better, all right? So this would be all of the lines for this particular figure. And again, you must list all and draw all possible lines. For our little lightning bolt, nope, doesn't work. What about our little moon? Hopefully you see that, oh man, doesn't have it. Okay, that's it. Have a good night.